So hi everyone, welcome to this research data management overview. I'm Julie Goldman, Research Data Services Librarian with Countway. And in today's session, these are some of the topics that I'm hoping to cover. So we'll talk about research data management, what it is. We'll delve into open science. We'll talk about the data services available at Countway. I'll talk about the Research Data Management Working Group and the Research Rigor and Reproducibility project work that I'm involved in. And then also talk about where you all can gain and build your own data skills. So to start, I've just included some definitions of research data and research data management. So data just refers to any entity used as evidence of phenomena for the purposes of research or scholarship. And data management is all about that active and ongoing management of that data through its life cycle of interest and usefulness to scholarship, science, and education. And research data management is all about managing the way data is collected, processed, analyzed, preserved, and published for the greater use of the community and also the original researcher. And we're all about visualizing this research or data lifecycle. And the lifecycle is a really handy way for us to provide a high-level overview of the stages involved in successful management and preservation of data for use and reuse. And there are many versions of this life cycle or process. So on the slide is an example that I have been using lately. And this research data life cycle is divided into 6 stages. First, planning for research data needs, collecting, generating, and storing data, cleaning, analyzing, and visualizing data for current uses, then publishing and sharing data, archiving and preserving data, and data and reuse. Ideally, the cycle continues when other people can discover the data that you create. And here I've kind of provided a summary of the activities in each of the stages and some of the common elements such as resources or tools. And this kind of gives you an idea of all the areas that may be involved at each stage of the process. And I'm involved in some, but not all of these activities. Research data management is a collaborative effort, so libraries must partner with our network of colleagues. And the data services the library does offer span the entire life cycle, and they're also provided in complement with other units across the university. So you can see that we refer people a lot, which I believe is one of our strong qualities. We are able to connect people and work in collaboration with others. So for example, we work closely with information technology and research computing to refer researchers where necessary, coordinating with sponsored programs to understand funding and data use agreement requirements, and partnering with other research support groups such as records management and bioinformatics to provide relevant teaching. So we can also include where those other units may be involved at each of the stages. So there are 3 categories of data services delivery that I offer, and the focus or topics of each of these can vary. So as our consultations, I'll run a consult with small groups or one-on-one about data-related topics. For example, I provide consultations on data management plans and data management practices like data documentation, project management tools, and data repositories. And it's very important to offer opportunities for people to learn more about data management as research practices, are constantly evolving. So I run monthly seminars with Megan from Research Records Management, and we do these on various topics. And we also partner with some of the groups that I've already mentioned to offer expertise where we cannot, such as storage or data analysis workflows. And then we also offer specialty help. So currently I'm embedded on a research team at Boston Children's Hospital as part of an NIH grant to enhance the research data management on their project. And I'm a part of our publishing and data services team. And our team is responsible for related services such as bioinformatics, scholarly communication, and digital scholarship. And this list is not exhaustive, but a subset of our website page. So looking at what I do support from this list, such as finding data and publishing data in repositories, education and support for data management, which we have seen encompasses a wide range of topics, including data sharing, and support for collaborative tools. And I think a basic principle of our team, we believe in providing researchers with tools and infrastructure to really focus their research and enhance their workflows. And also in this idea of kind of opening science. So what is open science? It's really an umbrella term of other things that you may be more familiar with, such as open access, open educational resources, open science, and citizen science. And at the core, open science is really enabling collaboration, contribution, and all of the research materials, data, and products that are available for others to view and use. So I saw this slide at a recent NIH workshop on repositories and thought it was a really nice way to visualize kind of all the elements that may get lost when we talk about managing data. So we may readily think about data management plans because they are becoming more and more required by our funders. And the term metadata is generally understood as information that you need to collect. So the terms at the tip of the iceberg are the things that we see. And the terms below the water, these are the things that may get lost in that research process. But they are generally very important to the success of a project. And it is becoming, standard practice to now share or even require some of these. So how can we ensure our work is open? This is another nice diagram that shows a research workflow and the steps you can take to make your work more open. You may be familiar with some of these. For example, we help with bibliographic and citation management and discovery. Open Science Framework is a project management system that can facilitate transparent reporting and publishing throughout a project. There are a few examples of other repositories here, such as the Noto and Figshare. And we can encourage use of open software with Jupyter or publishing preprints in bioRxiv, for example. And then, of course, Altmetrics really can show the impact of all of the work that we make available. So the last 2 years, we have used Open Access Week as an opportunity to advocate for open science. We offer workshops on software and resources that engage our communities, on use cases for using open tools, including many of the platforms that I've already mentioned, Jupyter, Open Science Framework, and making your work reproducible. And one of our newer services we offer is providing free premium accounts of protocols.io. And protocols.io offers a platform for people to share their methods and the method details before, during, and after publication. But they are also working to provide education regarding method creation, which is really key to facilitating reproducibility. You need the full picture of what someone did in order to reproduce or replicate it. And we are really excited to provide this support to our local community. So I've mentioned that research data management is a very collaborative effort, and the library partners with a network of people and groups to deliver data-related services and resources. So here's a list of kind of the major players that I interact on a daily basis. And here at HMS and on the Longwood campus, we are very fortunate to have this amazing network of people and groups that are all invested in data management practices and solving data problems in our community. So I recently stepped in as co-chair for the Longwood Medical Area Research Data Management Working Group. And our overall mission is to develop best practices to meet current and anticipate future research data management needs across our community. Our group meets monthly to provide a forum for the research community, and we have subgroups that tackle distinct projects related to resource aggregation and development and training. And our website shown on the screen serves as a landing page for those resources and training events, as well as more information about managing your data. And just as a note that we just rebranded ourselves, this group was formed, as the HMS Data Management Working Group, but we do have members from the School of Public Health and affiliate hospitals that come to our meetings and are involved in our project work. So we really wanted our name to reflect this wider Longwood Medical Area community collaboration and effort. So as I said, we have multiple groups working on distinct projects and topics, and I really want to share that work here. So I will go through each of these a little more in a little more detail, but see our website for all of our project statements and even our yearly goals. So DMP Tool is an online tool that you can use to create a data management plan. Megan and I actually did a data management plan webinar that provides a very nice overview of a data management plan and tutorial of DMP Tool, so I encourage you to view that. DMP Tool is maintained by the University of California Curation Center of the California Digital Library, and it includes templates for many of the large funding agencies that now require a data management plan with their grant applications. And Harvard is an affiliate institution, so you can log in with your Harvard key. And as an affiliate, we are able to provide university-specific guidance to help people complete their plan. This has been kind of a long outstanding project of the Harvard Library. And now with the NIH, very close to requiring data management plans for all grants, the Data Management Working Group thought it would be advantageous for a subgroup to take on this project work. So our DMP subgroup is working on customizing existing DMP tool templates with Harvard-specific information and example answers. Our research and training subgroup is focused on identifying training topics for our community and attending various orientations to get the word out about our working group and data support available. We also maintain a subscription list that we actively promote, and we send out quarterly newsletters and monthly seminar announcements. Our newsletters usually contain some update from the group, any events happening around Harvard, and any data-related news. So for example, our April issue went out last week, and we highlighted some upcoming training, COVID-19 data resources, and the Dataverse community meeting that will take place virtually in June. So feel free to subscribe if you would like to receive these updates. Next, the research workflows and metadata group is working to understand those research workflows in the lab and within research teams. An area we noticed that we could have an immediate impact on was the onboarding and offboarding processes. So while there are, administrative and lab safety procedures in place, we identified a gap in procedures related to data. So after talking with researchers and reviewing existing documents, we created these checklists for RDM-related activities. It includes steps and resources one should consider during these processes. And the group envisions these checklists will really address two challenges employees face. So when a new employee starts, most do not get any sort of research data management training directly from their PI. So the onboarding checklist can help initiate a data management plan and lab standards for data collection and storage. And this should really help with research consistency throughout a lab or group. Alternatively, when employees leave, they take their institutional knowledge with them. So the offboarding checklist really guides that knowledge transfer process to record that essential information related to projects and data sets. And this should ensure a smooth transition between lab members. No lab member leaves documentation behind for new lab members to join and continue the work seamlessly. And we have two versions posted on our website, a very comprehensive version and then a shorter abridged version. And our next project work will involve working directly with identified labs to really tailor these general guides for specific environments. So our website is a really growing resource for the LMA community and greater Harvard community. And over the last year, our website team has been working on website updates for content, accessibility, and platform. The site is currently an Open Scholar page, but we are working with the HMS web development team to transition to the Drupal 8 platform used by HMS. We also conducted usability testing on the website in the fall with the help of the User Research Center at Harvard Library. And you can read about this work in our report. Lastly, one of the more successful resources our group created is an ELN matrix that compares and contrasts the numerous electronic lab notebook solutions that are available today. And we provide this matrix as a way for researchers to identify an ELN to meet their specific research needs. Currently, our group or Harvard does not provide any recommendations or support for a specific ELN platform. However, our subgroup is involved in a project that will hopefully address the school's need and desire for a vetted solution. So if you are interested in data management, our working group, again, generally meets monthly, the first Thursday of the month. And these are open meetings, so everyone is welcome to learn about what we were doing and contribute to our efforts. And since we are, meeting virtually for the foreseeable future, please feel free to send me a note if you would like to receive a meeting invitation. So that's our work related to data management. And I really wanted to talk about another emerging area for libraries, which is reproducibility. And when I say it's emerging, this really means that we are mostly just starting out to offer services and support for reproducibility. And some libraries are even creating new dedicated positions for this area. And there are many ways to define reproducibility and replicability. And here I provide kind of two basic definitions. So at the core, reproducibility is where someone uses the same data, the same methods, and gets the same results. And replication is where someone maybe uses new data or new methods, but gets the same findings. And as I said, there's many different definitions, so you can kind of explore some of them in the paper that I've provided on the slide. And in order to achieve reproducibility, as included in that definition, all the necessary data and the computer codes to run the analysis must be provided. So we see here that reproducibility is a spectrum. from the publication only, which is not reproducible, to an article that includes links to the fully executable code and data for someone to reuse and reanalyze. This is fully reproducible and kind of what we call the gold standard. And I find it important to provide this reminder to people when I talk about data management and reproducibility. There are a lot of steps and processes involved to meet this gold standard. So you really want to focus on integrating 1 or 2 new practices into your research, and this will immediately make your research more reproducible. It is not all or nothing. And also, I like to remind people that each of these steps will benefit you, the researcher, first. So you might have heard of the so-called reproducibility crisis, and this term is nothing new. There have been articles about broken science for some time now on how it has been found that many scientific studies are difficult or impossible to replicate or reproduce. And a popular resource, to come out of this is Retraction Watch, which reports on when articles are under investigation or retracted. Sometimes this is due to, malicious or questionable research practices, but sometimes it is just due to reproducibility. Many cases could be, underlining this movement, such as, just the generation of new data and publications at such an unprecedented rate. And maybe also, the failure to adhere to good scientific practice and this kind of desperation, to publish or perish. People are moving quicker to get their work out there. So there are many ways to teach and kind of tackle reproducibility in science. And we have seen many organizations step up to counter the crisis through education and new institutional programs. And at HMS, we're one of the many institutions that have created some sort of reproducibility program. We are still very much in the beginning stages, but the HMS Research, Rigor, and Reproducibility Committee is responding to requirements from the NIH and also local research pressures. So this effort is being headed by the Office for Research Integrity, but like the Data Management Working Group, the committee is made up of a diverse group of stakeholders, and we are also engaging with faculty, as we know education and processes in the lab will ultimately have to reform. And again, we need to work with our faculty in order to change the culture related to the management and accountability of scientific research. And we have focused on these kind of 5 pillars and hope to develop training and resources for the entire research community around these kind of 5 areas. Some of the topics include research design, such as focusing on sample size and the concept of p-values. We see one of the pillars is data management, which we are lucky enough to already have kind of a strong program around. And other topics like scholarly dissemination. So how can we make sharing raw data, methods, and materials of standard practice moving forward? So focusing on these 2 areas, reproducibility and data management, you can't have reproducibility without proper project and data management. And with this overview, I hope you can see how kind of intertwined these concepts, data management, open science, and reproducibility really are. Data management is related, and its related activities are kind of fundamental for supporting the idea of findable, accessible, and reusable research. Open science is really driving a shift in the research culture for people to be more transparent about their work. And reproducibility is this gold standard that brings together data management principles and open science to, if we do believe science is broken, in order to kind of fix it. So to end, I just want to share some places where you all can build your own data skills. And there's 2 self-paced courses for research data management available for free on the campus network. So first, the best practices for biomedical research data management was funded by the NIH Big Data to Knowledge initiative. It launched in 2017, and these stats are current as of today. It's issued 282 certificates and currently enrolled 4,795 students worldwide. This course really focuses on the recommended practices for data management throughout this research lifecycle and highlights the importance of team science. And just a note, we've seen such an enormous surge in the course participation during the pandemic, which is really eye-opening to kind of this idea of open, free education and professional development available for people. And secondly, this newly launched Research Data Management Librarian Academy, RDMLA, is a partnership of 8 academic libraries, partnering with Simmons. And this is aimed specifically at librarians. It has nearly 3,000 participants in just the 5.5 months it's been live. This course addresses additional topics such as, advocating for data services in the library, project management and assessment, and also touches on data science skills librarians should have in order to offer more advanced services, such as data analysis and visualization. And you can pay a small fee for a continuing education certificate through Simmons University. So if you are looking for, kind of those more advanced skills, I'll also point to the carpentries, as all their lessons and materials are open and available online. And if you're not familiar, the carpentries is a community of volunteers that develop lessons, train instructors, and organize workshops in data management and software development best practices. And surrounding software, data, and library carpentry, these workshops and topics are for both researchers and librarians across many different disciplines. And I just want to give a shout out to the New England Software Carpentry Library Consortium, which this is a group of academic libraries that are jointly paying for gold membership to the carpentries. And through this membership, we are able to train carpentry instructors at a reduced cost. So this is really building data skills within the library workforce, giving librarians, more advanced skills to provide more advanced services. And Harvard Library joined this consortium because, we really like their pedagogy, and we also like the types of tools that are highlighted in the lessons, as they are typically what we find, faculty researchers and now librarians, they're currently using or need to use. And the goal of the carpentries training is really to build data skills. So if you're interested, we can arrange workshops or fund you to become an instructor, with a caveat, of course, of budget restrictions. And on the right, I've provided some of the top library carpentry lessons that I would highly recommend you to explore. And we can also offer workshops on any of these topics. So kind of to close, here are some reproducible research practices and data management principles to follow. Organize productively, accurately analyze, share your results, your methods, your materials, and doing all these activities, they will, really help accelerate science. So I'm happy to take any questions at this point.